We're trying to determine the coordinates of the point on the line y equals 2x minus 1 that is equidistant from 3, 0 and 2, negative 2. So I've graphed the points 3, 0 and 2, negative 2 right here. And to find any point that is equidistant from those 2 points, I need to find a point that's going to be on the perpendicular bisector. So if I connect A and B and I create a perpendicular bisector cutting through it, any point on this perpendicular bisector will be the same distance from A as it is from B. So my question is, at what point on here, on this line, and at what point on this line will the distance be the same from point A to point B? So essentially I'm trying to find the equation of this line, and also I'm trying to find where that intersects with y equals 2x minus 1. So I first need to find the midpoint to figure out what the equation is going to be. So the midpoint of A, B, I find by taking the average of the x values, 3, 2, which would be 5 halves, and the y values, 0 and negative 2, which is going to be negative 1. So the midpoint is right there, and I can use that to find the equation of the line that is a perpendicular bisector of that. So the perpendicular line is going to be the negative reciprocal of the slope of segment AB. So I need to find the slope of AB first. So to do that, I just use my slope formula. I'm going to take the the y values, subtract them. I'm going to get a 2, and then take the x values, subtract those. I'm going to get a 1. So 2 over 1, which is 2, will be my slope of segment AB. Now the slope of the equation of the line going that's a perpendicular bisector will be the negative reciprocal. So if this is 2, the negative reciprocal is going to be a negative 1 over 2. Now remember, the slope is going to be the same thing as negative a over b of a standard form equation of the line. So your a will be a 1, and then your b is going to be a positive 2. So a is 1, b is positive 2. So the equation of the line I can find by plugging a and b in for the standard form equation. So remember, standard form is ax plus by plus c equals 0. So I plug a 1 in for x, so I'm going to have 1x, and then plug a 2 in for b, so I'm going to get 2y. And then to find the constant part, I can plug in any point on the line. In this case I only know one point, the 5 halves negative 1. I plug that in for x and y. So in place of x I'm going to put in a 5 over 2. In place of y I'm going to put in a negative 1. So I get x plus 2y equals 1 half, which I would then, in order to put in standard form, I need to get rid of the fractions and bring the 1 half over to the other side, which I actually don't really need it in standard form completely. This is sufficient, but I need to get rid of the fractions, so to do that multiply everything by 2. So I'm going to get 2x plus 4y equals 1. So this is my equation of the perpendicular bisector that goes through segment AB. So the next question is to figure out where that line will intersect y equals 2x minus 1. So I'm trying to find this point right here labeled as C in the picture. So to do that, I can use either the elimination method or the substitution method in order to solve. So I have two equations, y equals 2x minus 1, and then 2x plus 4y equals 1. Substitution is probably the easiest in this case, so I can just substitute 2x minus 1 in any time I see a y in the other equation. So here I have 2x plus 4y equals 1. I can just plug 2x minus 1 in for y right here. So I'm going to get 2x plus 4 times 2x minus 1 equals 1. So I just solve this for x. I'm going to get 2x plus 8x minus 4 equals 1. And then 10x equals 5, so x would be 1 half. And then to find the y value, I plug the x value back into one of the equations. So I plug it back into y equals 2x minus 1. So I get y equals 2 times 1 half minus 1, which would be y would equal 0. So x is 1 half, y is 0, and that's going to be my answer.